Imagine a world in which, thanks to neural implants, people suffering from neurological conditions can regain control over the movement or easily communicate with others. Nowadays, despite different technologies used, brain interfacing solutions still require significant advancements to become a therapeutic treatment. One of the major challenges left is to scale down implant technology. The ENGINI project aims to develop a new generation of neural implants in the form of wireless network of multiple smart devices distributed within the cortex. They will be implanted below the dura, which is the toughest of the membranes surrounding the brain, to prevent infections and ensure good anchorage within the tissue. Implants will integrate electronics, wireless communication, and simple, robust design. There's many requirements to fulfill to have really successful implant for the future. Some of them seem to be very contradictory. Simply, at the same time, you have to make sure the probe's hermetic. We've had hermetic before. When materials we use, if you want to keep something very hermetic, the package grows larger and larger. And obviously for implants, you want to keep everything small. It has to be compatible with electronics encased within. So all the processes and materials have to be compatible with those for the electronics. So we have to keep the temperatures of the processing low. And that's challenging for the packaging, because the packaging methods we know, they often require high force, high temperature, high pressure, and so on. We can't use those. And at the end, we have to put this into human body, which is another great challenge, because it cannot degrade, it cannot harm body, and body has to be, and body cannot really influence it either. Our implants will resemble a drawing pin made of metal recording shaft and silicon glass electronic head. Such an approach takes an advantage of superior performance of macro wire recording. All methods of fabrication and integration of our probes take place in a clean environment, the same as in high-end electronics, that's providing consistently high quality. The research I'm working on will help to achieve future autonomous systems on a chip the size of a grain of rice. This will be safe and easy to implant and could not only help suffering patients, but create limitless opportunities outside of medical treatment.